Hi there, Professor Monte again. Let's look at equations that are reducible to quadratics. Okay, so I've given you some steps right here. One, we want to set the equation equal to 0, and then we're going to do what they call u-substitution. We're going to let u equal the smaller variable, and it has to be such that when we square that, we get u squared as the larger variable. And I'll show you what I mean when we do some of these. And then we're going to solve for u. We're either going to factor use the quadratic formula because these are quadratic equations. And then once we solve, we replace the original variable and then solve for whatever that original variable was. Okay, so let me show you what I mean. Got a couple examples here. This doesn't look nice to us. I don't know how to solve x to the fourth. I'm going to set it equal to 0. X to the fourth plus x squared minus 12 equals 0. Now, this sometimes, and this is one of those cases, you can factor this into x squared plus something and x squared minus something, and it's going to work out. But to show you this method, we're going to use this u-substitution. So I'm going to let u equal the smaller one, the x squared. Because then notice, if I square that, what's u squared, we may ask? Well, that's going to be x squared squared, which we multiply those exponents, it's x to the fourth. So this x to the fourth is really u squared. This x squared is really just u. And now I actually do have a quadratic because it's just squared. And then I can either factor or use the quadratic formula. This does factor. Let's see. It's u plus 4, u minus 3. Those are going to multiply the negative 12. They're going to add to the 1 equals 0. We set these equal to 0 and solve. I'm just going to do that. We're going to get u equals negative 4 and u equals positive 3. But I'm not done because I wasn't solving for u. The original problem didn't have u in it. It's x. I need to solve for x. But u is equal to x squared. So I can replace this u with an x squared. So x squared equals negative 4. And x squared equals 3. Now I solve those. Well, to solve the square root, to solve a square, we take the square root. Remember, we can only do that if we say plus or minus. So I get x equals plus or minus. Well, the negative under the square root becomes the I, and the square root of 4 is 2, so it's 2i. Plus or minus 2i. And here I can't simplify the square root of 3, so it's just x equals plus or minus the square root of 3. And I have 4 answers. I'm just going to leave it that way. If they want you to list them individually, you can. But I get 4 different answers. 2i, negative 2i, square root of 3, negative square root of 3. And I shouldn't be surprised I get 4 answers because I had an x to the 4th power. We'll see later in college algebra that the highest power is the number of answers you can get. In fact, you get that number of answers. They might all not be different answers, though. Okay, so that was one. Here's another one. I don't know how to do this. This may be one of those I isolate the radical and square both sides. But I'm going to use the same idea. I'm going to say, well, let u equal the square root of x. When I square that, I have to get this, which we'll see, because then u squared is the square root of x squared, which is just x. So this, x is really u squared, minus square root of x is just u. Quadratic again. This factors as well. Let's see, we get u minus 4, u minus 2. Those multiplied at 8, add to negative 6. So I get u equals 4 and u equals 2. But remember, u is the square root of x. So it's the square root of x equals 4 and the square root of x equals 2. And then to get rid of the square root, I square both sides. Now remember, when I square both sides, I don't have to say plus or minus. That's when I take the square root of both sides like I did before. But I have to check my answers. So this square cancels the square root. I get x equals 16, and I get x equals 4. Anytime I square both sides, I have to check my answer to make sure they're not extraneous. So put them back into the original problem. Don't plug them in here. Of course they're going to check there. Check here. And let's see, if I plug in the 16, let's see what I get. I'm going to get 16. Well, the square root of 16 is 4. 6 times 4 is 24. And then plus 8. 16 plus 8 is 24. That equals 0. That does check. So the 16 works. Let's try the 4. If I do the 4, I'm going to get 4. Square root of 4 is 2 times 6 is negative 12 plus 8. Again, that equals 0. That one checks as well. If one of them didn't check, I'd have to throw it out. Both of them didn't check, I'd have to throw them both out and say no solution. But in this case, they both check. I get 2 answers. They both check, so I'm in good shape. Okay, so there's some examples of that with the u-substitution, we call it. This is something that you're going to use if and when you go into calculus, but it's something, a u-substitution is something you can use to put an equation that doesn't look quadratic into quadratic form, and then you can solve by either factoring or using the quadratic